Now, the first theorem. Theorem number 10.1. Equal chords of a circle subtend equal angles at the center. This is a theorem. Equal chords of a circle means the chords are equal and its subtending angles equally. That means here in this picture, this is a circle with center O and AB as well as CD. These are the two equal chords. Which are the two angles that subtended at the center? This AB subtend angle is AOB. This angle, AB, this angle is the AOB is the angle subtended by the chord AB and COD is the another angle subtended by the chord CD. So what are the things given here? That is a circle with center O, AB and CD are equal chords, so AB equal to CD. And we have to prove that two angles, that is AOB equal to DOC. How can we prove? We are going to prove using the congruence relation. Consider these two triangles and if we are going to prove these two triangles congruent. What are the things we can get from the picture? AO equal to OD, that radii of the same circle, both are radius. So radii AO equal to OD. Then AB equal to CD, that is given. Both the chords are equal. Again OB equal to OC, that is also 2 radii. Then these three conditions we can tell that two triangles are congruent. AOB as well as DOC is congruent and because of the rule SSS. And last, angle AOB equal to angle DOC. That reason for that is a CPCT. So this is supposed to prove here, no, AOB equal to DOC, that we proved. This is the first theorem. You are supposed to write this theorem with proof in your notebook. Theorem number 10.2. This is the converse of the previous theorem, 10.1. Okay. It implies that if two chords subtend equal angles at the center, then they are equal. Converse of the first theorem. Next, we are going to study something about the perpendicular drawn from the center to the chord. Okay. About this topic or based on this topic, we have some theorems. So theorem number 10.3 is that theorem. This is a perpendicular, no? Perpendicular from the center to a chord. This is a chord. Here you see here AB is a chord. Sorry. AB is a chord and O is a center and OP is a perpendicular. If OP is a perpendicular drawn to this chord, then AP equal to PB. That means this P bisects or OP bisects AB. That is the next theorem. Okay, that is the perpendicular from the center of a circle to a chord bisects the chord. This is an important theorem. We apply this theorem to prove so many questions. Okay. So third, 10.3, the theorem statement is like this. The perpendicular drawn from the center of a circle to a chord bisects the chord. So this is the third theorem. You are not supposed to study the proof of this theorem, only statement we need. So next, two more theorems are there in the same section. Perpendicular from the center to the chord. In that section, two more theorems are there. What about theorem 10.4? That is the next theorem. The line that is drawn from the center of the circle to the midpoint of the chord is perpendicular to it. In other words, any line from the center that bisects a chord is perpendicular to the chord. That is the next theorem. That is a converse of the 10.3. That is 10.4. Okay. Then 10.5 means it is not related to these two conditions, but it is if there are three non-collinear points, then there is just one circle that can pass through them. Next section is about equal chords. That is, again in that section, two theorems are there. Equal chords of a circle or congruent circles are equidistant from the center. This also theorem only statement 1 to study. These are all important theorems. We need to apply these theorems to find out or to prove so many problems. So what is the statement here? Equal chords of a circle. Equal chords of a circle means the equal chords of a circle. AB one chord and CD the other chord. These are two equal chords. Then are equidistant from the center. Which is the center here? Center is O. And the distance from the center to this chord, that is OP. First AB chord. Okay. Then the distance from the center O to the chord CD means that is OQ. These two distances are equal. This is the theorem. Okay, that is equal chords of a circle. AB and CD are two chords, equal chords. AB and CD are two equal chords, and OP and OQ are two distances from the center. That two are equal. That is this theorem says like this. That is theorem number 6 of this chapter, and it is in the section equal chords of a circle. The next theorem, it is a converse of the previous theorem. Chords equidistant from the center of a circle are equal in length. If the chords are equal distance, that means OP equal to OQ, then we can tell that the length of the chords are equal. That is a converse of the theorem. That is OP equal to OQ, then we can tell AB equal to CD. So these are the two theorems in the section. Theorem number 10.6 as well as 10.7. Then we can move to the, based on these all theorems, some exercise problems are there. That exercise questions we are going to do now.